All right, today we're going to tackle a really common problem: how to give our bash scripts a memory. We're going to take them from being these forgetful one-shot commands and turn them into smart programs that can actually record data, track what they're doing, and tell a story using files and logs. Let's dive in. So, I want you to think about this for a second. By default, a bash script, it runs its commands, it spits them output on your screen, and then that's it. It's gone. It's got total amnesia. It has no idea what it just did, whether it worked or what errors it ran into. Today, we're going to fix that. So where do we start? How do we give our script its first memory? Well, we start by teaching it how to write things down. Let's look at how we can get information from inside the script and save it permanently to a file on your system. Check out how simple this is. You've got the command echo hello world, which, normally just prints that text right to your screen. But when you add this greater than symbol, the greater than, it acts like a funnel. It redirects that output and pours it straight into a file called file.txt. And if that file doesn't even exist, boom, it creates it for you. Pretty cool, right? Okay, this next part is absolutely critical to understand. A single greater than sign is like taking a whiteboard, erasing everything, and starting completely fresh. It wipes out whatever was there before. But two greater than signs, the double dash, that's totally different. That's like adding a new note to an ever-growing list. You keep all the old information and you just tack the new stuff onto the end. So just remember, greater than is for a fresh start. Double dash is for keeping a running history. Okay, so we've saved our data. That's step one. Now, how do we get it back? And maybe more importantly, how do we make our scripts smart enough to avoid errors by, checking if a file is even there before trying to read it? The fastest and easiest way to see what's inside a file is just using the cat command. It's short for concatenate, and all it does is dump the entire contents of the file right onto your terminal. It's perfect for just a quick peek. But for actually processing data inside a script, here's the real power move. Let's break this down. The while read line part tells the script, hey, I want you to grab one line at a time from a file, and for now, just call it line. The do and done section, that's where the magic happens. You can put any commands you want in there. Here, we're just echoing the line, but you could be doing some serious work. And that @file.txt at the very end, that just tells the loop which file to read from. This gives you amazing control. Now, here is a super simple trick that's going to save you so much frustration. Seriously, always check if a file exists before you try to use it. This little if statement here, if-f data.txt, does exactly that. It's basically asking the system, hey, is there actually a file called data.txt here? Trust me, if you skip this check and the file is missing, your script is going to crash and burn with some ugly error. This one little step makes your scripts so much more robust. All right, we've covered the basics of handling files. Now let's focus on one of the most powerful ways to use these skills: creating a log file. I want you to think of a log as your script's diary, a detailed minute-by-minute record of everything it did and when it did it. The entire point of a log is to build a history, right? You never want to erase what happened 5 minutes ago. And that's exactly why the append operator, the double dash, is your absolute best friend when it comes to logging. Every single new entry just gets added to the very end, creating this perfect chronological story of your script's journey. And look how easy it is to get a basic log going. First, we just define a variable for our log file's name. This makes it super easy to change later if we need to. Then, using echo and the date command, we add a timestamped entry saying, hey, the script started. And as our script does its work, we just keep adding more lines for important events. It's that simple, but it will make figuring out what went wrong so much easier later on. Okay, this is a great question. You might be wondering, so far, we've only logged messages that we wrote ourselves with echo. But what about all the output from the other commands our script is running? And what about their error messages? How do we capture all of that in our log? So let's break this down. Commands really have two main channels for output: standard output for all the good stuff, the successful results, and standard error for, well, the bad stuff. The first example, with just greater than, only captures the good stuff. The second one, with the two greater than, is special. It captures only the error messages. But that third one, greater all.log 2 greater than 1, that's the one you're going to use most often. It's the whole shebang. It sends both the good and the bad output to the exact same file, giving you a complete, unfiltered record of everything that happened. Whew, we have covered a lot of ground. So let's boil all of this down into a simple, handy reference that you can come back to anytime you need it. This right here is your money slide. If you take a screenshot of anything from this explainer, make it this one. This is the core of it all. These are the 4 essential symbols you will use constantly. Greater than to overwrite, double greater than to append, 2 greater than for just the errors, and 2 greater than and 1 to capture absolutely everything. Master these 4, and you have mastered the fundamentals of logging in Bash. And if you ever need to remember the core difference in a nutshell, this one line says it all. You use files to store the results or the data that your script produces, but you use logs to store the story of how your script did its work, its activity, its history, its successes, and its failures. So as we wrap things up, I want to leave you with this one thought. Try not to think of logging as just a boring chore for debugging. Think of it as a form of storytelling for your code. A really good log tells a clear, understandable story of what your script was trying to do, what it actually did, and what went wrong along the way. So my question to you is, what story will your next script's log tell?